which were on synthetic division. If you didn't take the notes last night, I'm not going to mark you down because I only said something about it yesterday morning, which was kind of last minute. And honestly, this is something you can pick up on pretty easily. So this is a continuation of the synthetic division notes. Don't make a pile yet, just have them out.
So with the worksheets that was there over the weekend, we are just going to picture those online?
Nope. The only thing you submitted online over the weekend was just like normal, was your polynomial long division notes. That's what's giving you attendance for Friday. And then if you submitted your synthetic division notes, that's great. And if you didn't do them, it's not going to count against you because I told you guys about the video so late. I mentioned it yesterday morning, so don't stress. Yeah, it was last minute. Okay, so synthetic division, we're going to do 2 examples. It only works for the really simple problems, which is why we don't teach you synthetic division first. We teach you long division first because long division works always. Synthetic division only works sometimes. But the reason we teach it to you is because it's really nice to be able to do something fast. And since it works in the simple cases and we often do the simple cases, they say like, okay, well, let's learn the fast way because it's kind of nice to have a fast way, especially since it works so often. So we're going to do m to the third minus 5m squared minus 11m minus 8. And we're going to do that divided by m plus 1. So synthetic division only works if you are dividing by something like this. So this is like a linear term. It's a binomial. That means it has 2 terms, and it's a linear binomial. And it's a linear binomial without a coefficient in front of the m term or the x term. So it's like really simple. So if this had been m squared plus 1, then it wouldn't have worked. So it only works if you have like x plus 1 or like x minus 3 or x plus 7. It's got to be simple. If you have like 3x plus 5, technically you can do synthetic division, but I'm not going to show you that because it starts to get complicated. So we only do it with these really simple ones. Anything more complicated than that, and we just do long division like normal, okay? And the reason we do that is because long division works every single time, which you guys were able to see in the worksheet after the activity where we did some with like taking a polynomial and dividing it by a quadratic where it had like 3 terms you were dividing by and one of them had an x squared in it and it started to get more complicated and you could still do it. Like it got more difficult, but it was still possible. So when we do synthetic division, first we take this and we solve it. So we'd say like m plus 1 equals 0 if we were going to show our work. We could show our work this way. M plus 1 equals 0, and then we would minus 1 from both sides. And then we would say, okay, if we solved that, m equals negative 1. And so then for synthetic division, negative 1 would go into the little box. And then from this part, we would make sure that we're not missing any of the values. So we have to the 3rd power, to the 2nd power, to the 1st power, and then no power. And then we would write down all the coefficients. So m to the 3rd technically has a coefficient of what? 1. And then we've got negative 5. And then negative 11. And then negative 8. And the first term always drops down. And the last term is always where the remainder is. So this part right here is going to be where our remainder comes from. Okay. So I'm going to drop down the 1. And then I'm just going to take this one and multiply what's in the box. So 1 multiplied by negative 1 is negative 1. And then I add these together. Negative 5 and negative 1 is negative 6. And then I take that and I multiply by what's in the box. So negative 6 times negative 1 is positive 6. And then I add those together. Negative 5. And then I multiply by what's in the box. Positive 5. Add those together, get negative 3. Okay? So then I say, all right, if I had an m to the third divided by m is what? M to the second. So m to the third divided by m is m to the second. And then I just drop by 1. M to the second, m to the first, no m. And then this is the remainder. And so the remainder is still going to be divided by m plus 1. And so the answer here is m squared minus 6m minus 5. And then the remainder was negative. So I've got minus 3 over m plus 1. So it's a shortcut, but it's a shortcut that only works sometimes, not always. Okay, here's another example. We're going to do 3n to the third minus 6n squared plus 6 divided by n minus 2. Okay. So for this part, we're going to say n equals 2. Okay. So 2 goes in the box. And then if we look at this, what do we notice here? We're missing a term. So this is actually 3n to the third minus 6n squared. And then what should I write? Plus 0n plus 6. And if you did the long division activity, did you guys notice that there was one problem that had the missing term on the end? Did everybody see that in the long division activity? I don't remember. Let me find it. It was, oh, it was this one. It was problem E. Problem E had x to the third minus 14x squared plus 45x. So it ended on an x, which meant that the missing term was on the end. Yeah, so you had to have a plus 0. Now, it ended up not messing up the problem. If you didn't have the plus 0 on the end, it did not mess up the problem, but only because this one didn't have a remainder because it went in evenly. If it needed a remainder, I think it would have messed it up a little bit. Or it would have confused you because it wouldn't have lined up. I think it would have been confusing. But with this one, it ended up being okay because it went in evenly. So the problem kind of stops suddenly. And then you go like, oh, well, I guess I'm done. But in problem E, you technically have a problem where the missing term is on the end. And that was kind of a weird one. Yeah. Okay. All right. So we have 3 and then negative 6 and then 0 and then positive 6. And we have our arrow. And then where the last number is, we have the little box at the end. That's where the remainder is going to be. Okay, so I start by bringing the 3 down, and then what do I do? 3 times 2 is 6. I add these together. 0 times 2 is 0. 0 plus 0 is 0. 0 times 2 is 0. 6 plus 0 is 6. Okay, so 3n to the third divided by n. So if you have n to the third divided by n, it would be n to the second. Okay, so n to the second, this would be n to the first, this would be no n, and then this would be the fraction n minus 2. So if we write our final answer, we have 3n squared. You can put plus 0n plus 0 if you want, but most people would not. And then this is a positive 6, so I'm going to write plus. I have 0.5 lead, which I should just not let myself use anymore. No, 0.5. But it's like any, like 0.7 I can use, 0.5 I just break all the time, you know?
But it writes so much.
It does. It writes so nice, but then it's, I just snap it like every 2 seconds. Okay. Okay. All right, so here's what I want you to think of next. So we're going to think of how factors, goodness gracious, we're going to think of how factors work. Okay. So let's think of all the factors of 24.
8, 3, 6, 4, 24, 1.
8 and 3, 12 and 2,
6, 4,
6 and 4,
1.
24 and 1. Okay.
Those are all your whole numbers there.
Okay. Is 5 a factor of 24? No. How do we know?
Because you can't multiply 5 times a whole number to get to it.
Yeah, 5 times a whole number doesn't multiply by something. 24 divided by 5 would not give you a whole number answer. What about 7? No, why not?
No whole number answer.
Yeah, 24 divided by 7 doesn't give you a whole number. If you do 24 divided by 8, what do you get?
3,
If you do 24 divided by 2, what do you get?
12,
If you do 24 divided by 6, what do you get?
4.
4. Okay, so you know that something is a factor if you can say that number multiplied by another whole number equals 24. Or if you could say 24 divided by that number equals another whole number. That's kind of how we say that numbers are factors. So we would say, like, let's write it this way. We would say 24 divided by 4 is 6. It goes in evenly. 24 divided by 8 is 3. It goes in evenly. 24 divided by 12 is 2. If I did 24, I could divide it by 5, but it wouldn't go in evenly. What would happen? You'd have a decimal. How many times does 5 go into 24?
3 times, or 4 times.
4 times. 4 times, and what's left over?
1.
With a remainder of 4. Do you guys remember doing that in elementary school? Yeah. 4 with a remainder of 4, so that means 4 and 4/5. Okay. If we wanted to know what 24 divided by 7 was, how many times does 7 go into 24? 3 times. How many are left over? 3. So that'd be 3/5. Oh, 3/7. Sorry, 3/7. Because the 3 is still being divided by 7. Yeah, because we would say 3, remainder 3. But that 3 is still being divided by 7. So over here, we would say something's a factor if the remainder is 0, if it goes in evenly. We would say something is not a factor if the remainder is not 0, if it does not go in evenly. Okay? So we're going to say something is a factor if it divides evenly if it has no remainder. We're going to say not a factor if it leaves a remainder when you divide. Okay, so what we're going to do is we're going to grab a color So if you need to get up, you can get up. We're going to grab a color. Okay, so I'm going to look back at my notes. Huh? Oh, go back so you can see it. Okay, so I'm going to go back to these examples we just did. Okay, so if we look at this example, what is our remainder? 6. So if the remainder is 6, that tells us that n minus 2 is not a factor of 3n to the third minus 6n squared plus 6. n minus 2 is not a factor of 3n to the third minus 6n squared plus 6, and I can tell because the remainder was 6, it did not divide evenly. Does that make sense? It's not a factor. Okay? Let's go back to that first example. We have a remainder of negative 3. What does that tell us about m plus 1? Okay, m plus 1 is not a factor of m to the third minus 5m squared minus 11m minus 8. Okay? Okay, what I want you to do next is I want you to grab your activity from Friday. Now, I'm not going to make you write the whole sentence, but let's figure out if these are factors or not. So, A. We're going to look at part A. So this is the activity from Friday. You did an activity. It had 12 problems. It was A through L. Yeah. N minus 2 is not a factor of 3n to the third minus 6n squared plus 6. There were just 12 problems total, but yeah. Okay, so on Friday, or whichever day of the weekend you happen to do it, there was an activity. It started with problem A. And problem A looked like this. And so what is our conclusion if problem A looked like this? Okay, so we're going to say x minus 1 is not a factor. Go ahead and write that next to A. X minus 1 is not a factor. Nope. We're going to shorthand it a little bit. X minus 1 is not a factor. Okay, what comes after A? G. Okay, let's look at the answer for G.
We have a remainder of negative 6, so x plus 8 is not a factor.
X plus 8 is not a factor. Okay. Okay, what comes after G? D. Okay, D was the next problem. And what did you guys notice about D? It's not a factor, okay? X plus 8 is not a factor for problem D because we have a remainder of 3. There's a remainder of 3, so we're going to say x plus 8. Okay. All right, what comes after D? L. All right, what do you notice about L? It is a factor because we have a remainder of 0. Okay, so for L, we're going to say x plus 8 is a factor. Okay, so in your separate color, I want you to go through each problem on the activity, and I want you to say if it is a factor, if what you were dividing by is a factor or is not a factor for every single problem. Okay? Is a factor, is not a factor. And then when you're done, we're going to make a pile. The pile is going to have these activities, and it's going to have the worksheet with the 4 problems. Okay? Cool. 1 through 4. 1 through 4. Are there any problems in 1 through 4 that we got stuck on? Should I do one of them? Number 4? Should I do any of the problems? 3? Okay. So if we look at number 3, something's missing in the problem we got to fix before we even get it started. So n to the 4th minus 6n to the 3rd plus 0n squared plus 0n, and then we can do minus 4. Okay, so I had to rewrite the problem for number 3 before I got started. And then what am I putting in the little box? N equals 6. Okay, so I'm going to start off by putting 6 in the little box. Okay, and then what should I put next to the box? 1. And then, okay. No, not 1. 0. 0. Negative 4. Okay. This one is going to drop down. And then this one is going to be where the remainder is. Okay. All right. So the 1 drops down. Then what do I do? 1 times 6 is 6, okay. Okay, those add to 0. 0 plus 0 is 0.
0 plus 0 is 0.
Okay, 0 times 6 is? Negative 4. Negative 4 plus 0 is negative 4. That's your remainder. Okay, so n to the 4th divided by n is
N to the 4th divided by
n to the 4th. Okay, so that's n to the 3rd, n squared, n, no n, and then this one is still going to be divided by n minus 6. Now, with all the zeros, we don't have to even write those down in our answer. So what should we write for our answer? Is n minus 6 a factor? No. We got a remainder. Okay. Okay, we're going to go back to our notes. So let's put this worksheet off to the side for a second. Okay, next on your notes, you're going to write the remainder.
Rick, I handed this message to you.
It's okay.
Will you use a different one?
You can use a new sheet of paper. That's fine. This is still synthetic division. Remainder theorem. I used less than half a sheet of paper. Yep, that's fine.
I think this much would be good.
Yeah. Okay. Remainder theorem. Okay. So here's the instructions. We're going to find f of 6. Find f of 6 if f of x equals -4 x to the third plus 29x squared minus 28x minus 8, and you cannot use a calculator. Find f of 6 if f of x is -4x to the third plus 29x squared minus 28x minus 8. And you cannot use a calculator. Ready, go. Yep. You're doing it without a calculator.
So this is what we do when we have
Yeah, we're learning something called the remainder theorem, and it's like a special trick that you'll see is kind of cool.
it's like a function.
We haven't got to the remainder theorem yet.
So that's not what we're doing.
We're not doing it yet. Whoa, don't bring Jesus into this. I'm just showing you why we care about the remainder theorem. Yeah, don't forget your order of operations. I've already snapped my lead 3 times. Yeah.
Why, what, 3 times?
Snapped my lead. Okay, I think I got it. How are you guys doing? I know, I'm gonna wait. Not everyone is the math master, such as me. She said humbly. What did you get? We got different answers. 2 against 1. We have 2 answers that are 180. That's when you're solving an equation. When you do PEMDAS forwards like normal, that's when you're evaluating an equation, which is what we're doing right now. Yeah. Yeah, if you're solving for x, then you go backwards. If you're evaluating, which is what you're doing right now, you do PEMDAS forwards. Yeah. Okay, I'm going to give you 1 more minute because we have a limited amount of time today. All right. All right. We're going to move on. I'm going to show you something. I'm not going to show you. My answer is hidden. I'm going to show you something. Now, you're probably wondering, Miss Rice, how does this even apply to what we were just learning? Well, let me tell you. The remainder theorem, the word remainder makes you think of what? Dividing. It makes you think of dividing, and you have something left over. You have a remainder, okay? So what we're going to do is we're going to say, okay, let's take negative 4x to the third plus 29x to the second minus 28x minus 8, and we're going to divide it by the factor, which would have been used if you were plugging in a 6. So if you were plugging in a 6, what is the factor that they would have been using? X minus 6 is the factor. Okay. So now let's do synthetic division on this problem. Okay, and let's see what the remainder is, and then we'll see what the remainder theorem is all about. So if we have, this means we're going to have a 6 in the box, right, because x equals 6. Okay, so far we can see that this is related to the original problem because in the original problem we were plugging in 6. So we can see right now, okay, we're dividing by the factor. Yep, so we're writing all of this down. Okay, and then if we set up this problem as synthetic division, then what should I be writing next?
You should be dragging down your coefficients.
Mm-hmm.
Negative 4, 29, negative 28, negative 8.
Okay.
And then you drag down negative 4.
Now, this is called the remainder theorem. So what do you guys think is going to be special about this problem? The remainder. I think the remainder is going to be something special about this problem. Okay, so I'm just going to circle that. I think that's going to be special. Okay. All right, so I'm going to drop down the negative 4.
Negative 6, I mean, negative 4 times 6 is 20, it's negative 24.
Okay.
You get 5 left over.
Okay, so 29 plus negative 24 is 5.
6 times 5 is 30.
Okay.
Negative 28 plus 30 is positive 2.
Okay.
2 times 6 is 12. Negative 8 plus 12 is 12.
Okay, did anyone get 4 for the answer?
Yes.
Oh, I did. Ta-da! So let's check this. Let's check this because not all of us got 4, but let's double check and see.
I was relying on Taylor's.
Okay.
Exponent skills.
So let's see if the answer really is 4. So negative 4 times 6 to the third plus 29 times 6 to the second minus 28 times 6 minus 8. The answer is 4. So listen carefully because this is the remainder theorem. The remainder theorem says that if you wanted to evaluate a function for a number and you don't have a calculator, all you have to do is synthetic division and the remainder is the answer. The leftover number is the answer. That's what the remainder theorem says. Now, you don't have to do it by hand, you can just do that. Now, most of us are like, well, that's great. We're going to use a calculator and just plug it in. Except the people who write the EOC love the remainder theorem, and they have come up with all sorts of really fun questions to force you to use the remainder theorem in really creative ways. So let's go ahead and let's get our worksheet back out because I have written some remainder theorem questions to show you how creative the EOC people are. So they're very creative. So we're going to use the remainder theorem on the rest of these questions. I'm going to help you with them. Number 5 is a very straightforward remainder theorem question. So let's go ahead and let's get it set up, and we're going to use the remainder theorem. We are not going to use our calculators. So if I wanted to use not use my calculator, but if I wanted to do the remainder theorem instead, what would I do for problem 5? Wait, is it -3? Because what would the factor have been? X minus 3 is what would have been in the parentheses, so positive 3 really is what goes in the box. Okay, positive 3 goes in the box. All right, is f of x written the way it should be? Does it have every single thing?
No, it doesn't have the
X squared. Okay, so it needs x to the third plus, then what should it have? 0x squared minus 10x minus 24. Okay, so what I want you guys to do is I want you guys to go ahead and look at the rest of the synthetic division for this problem and see if you can find the remainder. All right. So at this point, we should have number 5 done. Yes. Okay. Let's look at number 6. All right, on number 6, it says, it's worded weirdly, but the problem is actually not terrible. It says, if k is a constant, what is the smallest value of k such that the polynomial is divisible by x minus 1? Okay, so here's what we're going to write out. We're going to say k squared x to the third minus 7kx minus 18 divisible by x minus 1. Now, if something is divisible, what does that mean about the remainder? There is no remainder. It means there has, yeah, if I said 24 was divisible by something, that would mean that it has a remainder of 0. So the remainder is 0, okay? So let's spell this out. So we're going to say if it's divisible by x minus 1, then we're going to say the remainder is 0. And there are a couple different ways we can do this problem using the remainder theorem, okay? We can do this with synthetic division, or we can kind of fake it, and we can say, I don't want to do synthetic division with this problem, I want to do evaluation with this problem. Because I know that synthetic division and evaluating are technically the same thing. Does that make sense? I know that synthetic division and evaluating are the same thing, okay? So I know if I did synthetic division, my remainder would be 0. I know that if I did evaluation, my answer would be 0, okay? So let's set up the problem to do it 2 different ways, and let's see what would happen depending on the way that we choose to do it, okay?
We already know the answer, don't we?
Well, the answer that we want to find for this problem is k. Okay, so x equals what for this problem? 1. Okay, so what we know is that if we were to plug in 1, we would get 0. Does that make sense? If we plug in 1, we get 0. Okay, so if we were to do the evaluation method for the problem, we would say k squared times 1 to the third minus 7k times 1 minus 18 equals 0. This is the evaluation method. So if I plug in 1, I get 0 as an answer. Does that make sense? Okay. The other way I could do the problem is I could do it with synthetic division. So I could say if I do the synthetic division process, my remainder is going to be 0. Okay, so the synthetic division process says take the 1, put it in the box, take my coefficients and write them down. Now if I do my coefficients, I have a term missing. What term am I missing in this problem? X squared. I have an x to the third, I have an x, I don't have an x squared. So what should I write right in the middle for the x squared? 0. Okay. So if I write my coefficients, I'm going to say the coefficient for x to the third is k squared. The coefficient for x squared is 0. The coefficient for x is negative 7k. The coefficient at the very end is negative 18. And then I already know that at the end, I have a remainder of 0. Does that make sense? Okay. So now I'm going to go ahead and go through this problem. I'm going to say drop the k squared down. K squared multiplied by 1 is what? K squared. 0 plus k squared is what? K squared. K squared times what? K squared times 1 is k squared. Negative 7k plus k squared. Do you guys feel like this is the easiest way to do the problem? It feels like it's getting a little complicated to me. Yeah, negative 7. So it's yeah. So this would be negative 7k plus k squared.
It's negative 6k to the second.
Okay. And then that multiplied by 1. Ugh, I just want to do this one over here. Are you guys okay with that? Okay. So I'm going to say this feels a little complicated. I got intimidated real fast with this one. I'm going to choose to do this one over here. Are we okay with that?
Yes.
Okay. So over here, I'm going to say I've got k squared minus 7k minus 18 equals 0. And how do I solve something that looks like this? It's got a k squared, a k, and a number.
Oh, it's
I don't square it. It's a quadratic. I factor it. So I'm looking for two numbers.
9 and 2. Negative 2 and negative 9.
Yeah, so I was looking for two numbers that multiplied to negative 18 that added to negative 7.
2 and negative 9.
And the two numbers were negative 9 and 2.
Bro, I don't even know where we're going with this. We're going so many directions.
It was so easy.
I told you everything was up in that. K equals 9 and negative 2.
Okay, and so which value of those is smaller?
Negative 2. Why is it the smaller value?
It says, what is the smallest value of k?
Oh, right.
And let me guess, can you give a number where you have a slide and divide?
I mean, they could do that. So the part of this problem that used synthetic division was this part right here. Okay.
So would you get 2 answers for the other one?
Yeah, so with this one, it's possible that we made a mistake somewhere. I'd have to look more closely at it. But usually with the synthetic division, you have like two ways that you could kind of set it up, and then one way seems a little bit easier, and then I kind of default to that one. Yeah. Okay, let's look at the next side. So the same thing. We're going to have two different ways that we can think of this, okay? Are you guys ready? We're going to have two different ways we can think of this, okay? So it says we have the graph of a polynomial. It says we have f of x, and it's divided by x minus 3. Okay, so I'm going to write it this way. I have f of x divided by x minus 3. So we always have two ways to think of the remainder theorem, right? We have the way where we think of it like this, where we think of it as plugging a number in and getting an answer. And then we have the way where we think of it like this, where we have the remainder theorem, where we do the synthetic division and we get an answer and the remainder is the answer, okay? Those are our two different ways. And it says, what is the remainder when f of x is divided by x minus 3? What answer do you get, okay? So we're going to set this up the two different ways, and we're going to see which way helps us to get to the final answer, okay? I just set it up both ways, and I see which way can I get there, all right? So if we're taking f of x and we're dividing by x minus 3, then what number would we be using for our synthetic division? X equals 3. Okay, so I would have the 3, I'd put the 3 in a little box, and then f of x, if I knew what that function was, if I had more than just a picture of it, I would be using the coefficients of f of x right here. Does that make sense? I don't have them. I can't do the problem this way. But if I had them, I'd be putting them right there. Does everyone understand that? And I'd be dropping down the first coefficient, and I'd say, okay, the remainder is my answer. That would be my answer right there. That's what they're asking for. Can I do the problem that way? I cannot do the problem that way. Okay, so the other method is to say, okay, I can't do the problem this way, so my other method is to say, if I plug in 6, 4 is the answer. If I plug in the number in the box, the remainder is the answer. Does that make sense? If I plug in the number in the box, the remainder is the answer. So I'm going to go up here and I'm going to say, what's the number in the box and how do I get the answer? So we are going to plug in for this problem. What number are we going to plug in? 3. So we're going to take f of x, we're going to plug 3 in, and we're going to see what the answer is. So over using the graph, how do we see what f of 3 is? How do we plug in 3? Is 3 an x value or is it a y value? It's an x value. So we want to plug in 3. We want to plug in an x value of 3. Here's the x value of 3. If the input is 3, how do we find the output?
Frick.
Anyone know what the output is?
Is it 0? No.
It's not 0 because the graph doesn't hit right here.
Oh, it hits at 2. No. It hits at
Doesn't hit at 2.
5.
Does it touch at 5? Is that where it crosses right there? At 5? Does it look like it hits at 5 or 6 or somewhere in between? Are you guys sure?
No, it's 6.
I feel like it crosses at 6.
It hits 6.
Do we feel like are we okay with it saying 6?
Yeah.
Okay. So if this is the point 3, 6, then this means if you plug in 3, 6 is what you get. So if we did function notation, we would say if you plug in 3, 6 is what you get. Does that make sense? Yeah. So if you plug in 3, 6 is what you get. If you did synthetic division with 3, 6 would be the remainder. So these problems on the EOC, they are what we call conceptual, which means that they are getting at your understanding. They are not skills difficult. They aren't something where you have to do a lot of math by hand, because we're doing hardly any math by hand. Are you guys noticing that? We're not number crunching. We're not doing a lot in our calculators. We're not doing a lot by hand. But conceptually, they're very difficult. We have to really understand what we're doing. Does that make sense? Okay. All right. We have 3 more problems to do. We're going to try to do these 3. I'm going to say try number 8. Give number 8 a good shot. And then I have to look and see what our video is tonight.